Hello, my name is Adam. In this video, we are going to learn how to make Frogger in Unity. Frogger is an action game developed by Konami and manufactured by Sega as an arcade game in 1981. The player directs each frog to its home by crossing a busy road and navigating a hazardous river, scoring points along the way. In the video, we will cover topics such as sprites, collision, and even slightly more advanced topics like coroutines. If you need help at any point in the tutorial, feel free to join our Discord community where we can offer direct help. There's a link in the description of the video. Please consider subscribing to the channel to support the amount of effort it takes to create a video like this one. It is completely free, but it helps me a ton. Thank you. Enjoy the video. Alright, let's begin by creating a new project using the Unity Hub. In the top right corner, we can select the blue New button to create a new project, and we can click the drop down next to it to select the specific version of Unity we want to use. This will depend on which versions of Unity you have installed. For this tutorial, it won't really matter that much which version we use, but I will be using 2019.4. Really, that version or anything above it, 2020 and 2021, it really won't matter. We're not going to be using any like specific features that are only available in one version, so probably just 2019.4 or above and you'll be good. So I click that, it'll open a prompt here where we can name our project. So I'm just going to call this Frogger. Choose wherever you would like to save your project. And most importantly, click the 2D template here on the left. This is going to be a 2D game. So this is going to install a number of 2D packages that we're going to be using throughout this project. Click the create, and then this might take a couple minutes to initialize. So we'll pick it back up as soon as it's finished. Once your project has finished initializing, you should see something like this. By default, Unity creates a sample scene that we can see here. This sample scene contains one game object. On the left is our hierarchy where we can see all of the game objects that exist in this scene. So if we select one, then on the right in our inspector, we can see all of the components and various properties associated with that game object and those components. So by default, we just have a camera here. And we're going to change everything. We're going to add new game objects and so on. But before we do that, we need to import some sprites that we can use to decorate and create our scene. So let's go ahead and do that first. All the sprites I'm going to be using will be available on GitHub. So let me pull that up real quick and show you. There will be a link in the description of the video to open GitHub here. Once you're on this page, you can click the download button. This will download the full project. And then within that project, find the assets and then the sprites folder, and you'll have all those available sprites. There's also a Photoshop file that contains everything if you have Photoshop, but otherwise, sprites folder will have everything. You definitely don't need to use the same sprites I'm using. Feel free, and I even encourage you to create your own sprites. And if you don't want to use custom sprites at all, you can completely just use basic sprites that Unity itself offers. So for example, in Unity, if I were to right click in my project panel at the bottom, I can go to create sprites, and then there's a couple just basic shapes here. For Frogger, the entire game could be made with just basic square sprites. So whatever you choose to do, it's up to you. But if you want to follow along, use the exact same sprites I'm using, then they will be available on GitHub. So let me go ahead and just drag these into my project. Actually, first, let me create a new folder. I'm going to call this folder Sprites to keep everything organized. Let me just drag these in. All right, so we have imported those. Now, when you import any kind of file, whether it's a sprite or whatever, there's going to be various settings associated with that. So if you click on one of these, in the inspector here, we can see the import settings for this file. For all of these sprites, if you are using the same sprites that I am using, we need to change some of these settings. Mainly, we need to change the pixels per unit here. All of these sprites were designed to be 16-bit. Most of the sprites are 16 by 16 pixels. So we want to change the pixels per unit to be 16. And then secondly, we want to change our filter mode here from bilinear to point. Point is, if you're doing pixel graphics, you usually want to use point because the bilinear and trilinear is going to change how it's kind of aliased and so on. And it's usually going to actually remove the kind of pixely look to it. So if you're creating pixel graphics, you usually want to keep that pixel style, and so point here is usually the best for that. And then finally, the only other thing I'm going to change is the compression, or not the compression, the format to RGBA 32-bit. And that's really all we need. So if we apply those changes, and by the way, I selected all of them, and if I select all of them, you can see at the top 19 texture 2Ds imports. So there's 19 different files here that I'm changing all at once. So much quicker than doing it one by one. So that's it in terms of importing our sprites, and then we can start to utilize those in our scene. Let's start with our camera since it already exists in our scene. So if we select a camera, we can look at our components on the right in our inspector. The only thing I'm going to really change here is our background color. I'm just going to make that black. And then I'm going to change the size as well. What the size is going to do is essentially kind of zoom in or zoom out. For an orthographic camera, if you see here as I change the size, it's essentially giving us more or less space to work with. And you can kind of think of it as zooming in or out, although not exactly. But for our purposes, I'm going to increase this from the default of 5 to around 7, which will give us a little bit more space to work with so we can fit everything we need to for our scene. And we're probably going to adjust this a little bit more, but for now that should be fine. The other thing we want to change that sort of relates to our camera is the aspect ratio of our game. So if we look at our game tab here, there's a drop down that allows us to set the aspect ratio, or at least preview our game with this aspect ratio. When we build the game, we'll have to change it again, but I'll show you how to do that too. But for previewing our game, we want to have a sort of an aspect ratio of about 14 by 16, which is going to allow us to fit everything for Frogger. So you can see I've already created one, but for you, you're probably going to click this plus button. And then from here, you can name this whatever you want. Maybe call it Frogger, maybe call it 14 by 16, and change it from fixed resolution to aspect ratio. And then you can do 14 by 16. And so I'll select that. You notice how this changes kind of our viewport here. And so this is a little bit more kind of the layout that we want for our game. And then the important thing here is when you eventually go to build this game, if you go to make a build of the game, you're going to want to change something in your project settings. So let me just go over that now, even though it's kind of getting ahead of ourselves a little bit. If we go to our project settings, which you can access from Edit, Project Settings, then find the Player tab here, go under Resolution and Presentation, and find the default as native resolution. So what that's going to do is when you build your game, it's going to make the resolution be whatever your monitor is, 1920 by 1080 most likely. It's not going to be this 14 by 16. So if we uncheck that, we can set the default screen width and default screen height. So if typically, 1920 by 1080 is kind of what most games are designed around, which is a 16 by 9 aspect ratio. So let's keep that height of that, 1920 by 1080. So let's keep the height. But if the width is 14 by 16, like what would that translate to be? So let's do a little bit of math here. If we do 14 divided by 16, we know the width is 0.875 times whatever the height is. So now if we times that by 1080, we get 945. So if we set this to 945, now when we go and eventually build our game, it will match the aspect ratio that we set here when we preview it. So that's just something to keep in mind. All right, let's add our water and road to our scene next. If we just simply select one, let's start with the water, for example, and we just drag this into our hierarchy, it's going to create a new game object. It's going to add a sprite renderer component to it, and it's going to assign the sprite already for us. And we can see it being previewed here on our scene. All we need to do is reposition and size it. So let's set our scale in the x-axis to about, let's say 16. It's okay if it exceeds the bounds of our camera, because we might adjust that a little bit later. So I'm going to sort of intentionally make it a little bit bigger, just so we know it's going to for sure cover the entire area. We want it to be exactly half of our scene here. So If you remember, our aspect ratio is 14 by 16, so half of 16 would be 8. So let's set that to be 8. And then to offset it, let's do positive 4. There's our water at the top. Let's do the exact same process for our road. We're going to select that, drag it in, scale it to 16, set the Y to 8, and let's bring it down to -4. And then we've got our water and our road, and they kind of meet right in the middle. And now we can add our medians here. So if we select our median, same process, just drag that into our scene. We set our scale to 16. You'll notice a problem already. This is stretching when it needs to tile. So what we want to do is change our draw mode on our sprite render from simple to tiled. And we need to set our width here. Now, we actually don't want to set the scale. We actually need to set this back to 1. And instead, we set that in our width property here under the tiling. So 16 there. And now you can see that it tiles perfectly. Now, there is a little warning here, and this has to do with the import settings for this particular asset. Let's select that asset. Let's change the mesh type from tight to full rect. And let's go ahead and change the wrap mode to repeat to indicate that the texture is repeatable. And let's apply those changes. And that'll get rid of that little warning. It honestly wouldn't have really mattered anyways, but just to suppress that, it's good practice to kind of fix any warnings you might experience in your project, because you never know when later on they might come and cause problems. So there's our first median, and this median's already positioned where we want it. We want it right in the middle between our road and our water, so that one's good. But we need another one at the bottom. So let's go ahead and duplicate this. We can right click it and select duplicate. You can also press Control D, or if you're on Mac, Command D. And let's position this one at the bottom. So I'm going to set the Y here, and let's do about -6. It should meet up with the edge of our camera here. So let's see, maybe 6.5. Yeah, there we go. And we might adjust these a little bit later, but this is good for now. And once again, right at the edge of where our camera meets. If we go to our game view, there we can see a better indication. And there should be exactly 5 rows for the road. So like, for example, if I were to duplicate this, there's 1, 2, 3, 4, and 5. So yeah, there's 5 rows in between, which is exactly what we want, but we'll get to that next. For our cars, it's going to mostly be the same process. However, there are a couple new things we need to do. So for one, there's going to be multiple cars along a single row. And of course, there will be 5 different rows of cars, which is why we have 5 different sprites here. But the most important thing is we're going to need to create a prefab for our cars, because there's going to be multiple of them. And therefore, if we ever decide we want to make a change to a car, we want to apply that change to all of the cars, or all of the cars of the same type. And so that's what a prefab will allow us to do. So let me walk you through that process. First, let's go ahead and just follow along with what we did for everything else. Let's drag in, let's say car 1 into our scene, and this is going to be on the first row. I named these just after the rows. It'll be, they're in the order that they'll show up on the road, although it doesn't really matter. You know, feel free to do whatever you'd like. Once this is in our scene, let's position it at negative. Let's see, our median here was -6.5, so this should be exactly 1 unit difference, so -5.5 instead. And there's car 1 with our sprite render. And let's add a couple of new components to this car. So we're going to need a collider. So if we click add component, we can search for box collider, and then we're going to use the 2D version since this is a 2D game. A collider is going to define the collision area of an object, and this allows us to detect when some other object has collided with us. So in our case, we need to know when Frogger collides with a car, or vice versa, because that is going to indicate the Frogger is going to die and lose a life. And so we need the collider to give us that data. And importantly, we want to set this to be a trigger. All of the colliders we use for this game will be marked as triggers. The difference between a trigger and a non-trigger is that a non-trigger is like a physical object. So imagine it's a wall. And if you were to collide into that wall, you would physically stop you'd hit the object, you'd come to a stop. It's actually going to simulate physics on our objects. You might be thinking, well, don't we want our car? Our car is a physical, real object, but for our game, all we need to know is that Frogger has hit the car, therefore Frogger dies, and so on. We don't actually care about simulating the physics that would happen from like Frogger bouncing off of the car when they collide and so on. We just want the data. We just want to know when they have collided. We don't care about the physics simulation. So we're going to mark that as a trigger. And let's turn this now into a prefab. And eventually we'll probably add more to this, but for now, let's start with this. So to create a prefab, all we need to do is drag this into our project panel. But first, let me create a folder that will contain all of our prefabs. Let's just create a folder, prefabs. And if I drag this in here, it now turns it into a prefab. You can see it says car1.prefab. And so now later on, let's say, so let me show you now. Let's actually finish doing this row. So let's say we're gonna have 4 of these. Let's duplicate this 4 times. And let's just focus on their positions. Let me figure out what their position should be real quick. Okay, so yeah. So let's give one of them a position of -5 in the X. And then I believe they're spaced every 4. So -2 or every 3. No, it's every 4. So this would be -1. And then we'll have +3. And then we'll have +7. So there's our 4 cars. And these will loop around. We'll get to that. But for now, this is good. And so notice in our hierarchy, it shows up as blue to indicate this is an instance of our prefab. And if I were to make a change to our prefab, so if I selected our asset and I made a change, let's say I changed the sprite. Let's say I just changed it to a different car. Notice how they all just changed. I only changed the prefab itself, but it applied it to all of them. So that's the benefit that we're going to have by using prefabs. And that'll be important just as we're making our game. We might need to make some changes, iterate on the objects, and it's going to be tedious to have to make those changes individually for every single object. So we'll do that for all of our cars. So let's follow this exact same process for our other cars as well. So let's start with car 2. Let's drag that into our scene. We'll move it down to -4.5 this time. Let's add our box collider 2D, mark it as trigger. Let's turn this into a prefab. And now we can go ahead and duplicate this a few times. Let's add 3 of these. And let's position them. We'll keep one at 0 where it is. And let me see here. We'll do one at -4. And the other at +4. And the positions here, like, they don't really matter. You really can position them however you want. And this is one of the ways you can add difficulty to your game. So if you have more cars or less cars, that's going to change, how hard the game is. How spaced out they are is going to change, how difficult the game is. So, feel free to kind of position them however you want. I'm just going to kind of follow the way I set it up in my other project, just because I found it to be kind of the most optimal, or I just enjoyed the balance it created with the gameplay. So there's car 2. Let's do the same thing for the others. Let's drag in car 3. This one will be -3.5. And let's add our box collider 2D, mark it as a trigger. Let's make this a prefab, so we drag it into our project panel down there. And let's add 3 of these. So I'm going to duplicate that 3 times. And we're going to position these actually the exact same way, -4 and +4. Let's go ahead and do car 4. Drag that in. This one will be -2.5. And let's add our box collider 2D. Trigger. Turn it into a prefab. And you might have just realized something. Why don't I see it showing up? It's not displaying. And that's because it's behind our road. Not really sure why it didn't do that for the others, but this is actually a problem we need to fix regardless. Our road and our water are sort of the most background elements. So we want to guarantee that those always draw first technically. and then everything else will draw after on top of our water and road. So the way we can change that is by selecting our road here and changing the order and layer under additional settings. Let's change our road to be -1, and notice now we can see our car because our car will be rendered on top. Same thing for our water. Let's change our water to be like -2. I would imagine the water is even more sort of in the background, although it probably doesn't matter in this case. But regardless, let's make those negative. Everything else will be kind of zeroed out to guarantee they render on top. And let's get back to our car here. So there's car 4. Let's add just 2 of these. These ones are going to be really fast. So we're just going to have 2, and we're going to position them all the way on the kind of far left. They're going to actually start off screen and then zoom in. So I'm going to position one at -7 and one at -10. So that's -10. Let's do -7 here. Okay, and then let's do our final car. Car 5. Drag that in. Add our box glider. Mark it as a trigger. Turn it into a prefab, and let's add a few of these. Let's add 3 of these. 1, 2. Oh, I forgot to position them. So let me change the position here. -1.5. Alright, so -1.5. Let's duplicate this 3 times. 1, 2, 3. And let's see. Let's do one of them will be -3. One will be 2 and 7. 2 and 7. So these ones are spaced out by 5 units. Okay, and there's all of our cars. Now you might already notice that the alignment here doesn't seem to match up. There's a little bit of a gap between our median and our cars actually. So this is where we're going to need to adjust our camera actually a little bit more. I thought this would come later, but let's go ahead and just do it now to get it out of the way. So I've already kind of worked it out to figure out what exactly it should be to make sure we have space for everything perfectly, as well as a little bit of a gap at the top so we can display some UI like score and lives. So we just want to adjust our camera size to be 7.25, just a little bit bigger. And then for all of our objects here, we need to adjust them a little bit. This median in the middle should still be where it is. However, the one at the bottom, and I just realized I have an extra median. I don't know why I have an extra. Let's delete that. Our median at the bottom should be at -6 exactly. Basically, everything is going to shift up kind of half a unit. So let's do our cars. This would be -5. Car 2, -4. Car 3, -3. Car 4, -2. And car 5 will be -1. And there they line up a little bit. And there is a gap at the bottom now, which is actually not really a problem, but we want that gap at the bottom to really be at the top, because that little extra space there is where we're going to put some UI. So we can instead change our position of our camera, right? So if we adjust the position of our camera to be 0.75, yeah, 0.75, and now that sits perfectly at the bottom, will give us a little bit of extra space on the top to put some UI. All of our cars line up exactly 1 unit apart, and so we're all good there. We fixed that problem. I'm going to adjust these two while I'm at it, our prefabs. The transform on our prefabs don't really matter too much, but just for clarity, I'm going to adjust all these. And this will give us kind of, it's a little bit easier to understand that like our Y value is essentially what row they're on, right? So if the median in the middle there is 0, then, you know, car 5 is -1 row, you know, -2 rows, 3 rows back, 4 rows back, 5 rows back, etc. It's a little bit easier to understand that way instead of using like 0.5 and so on. Okay, now let's go ahead and do our water elements. It's going to mostly be the same process as our cars, but once again, there will be a couple new things we need to do. So the first row in the water is going to be some turtles. And there are going to be groups of 3. So there's going to be 3 turtles next to each other that will form sort of one platform. And then there will be a gap, and then there'll be another set of 3 turtles, then a gap, then another set of 3, and so on. So what we actually want to do here is create a prefab just for a single turtle. And then we also want a prefab for a group of turtles. And this is because we're going to have different groups of turtles. So if we want to make changes to all of the groups at once, we can change that prefab. But if we want to make a change maybe to the individual turtle, it'll apply to everything and to all groups. So let's start with just the individual turtle. Let's find our turtle sprite. I'm just going to do the first one here. Let's drag that into our scene. We'll position it. This one, we'll position this at row 1 or 1 above the center line. Let's go ahead and add our box collider 2D, mark it as a trigger. And let's turn this into a prefab. I'm going to just name this simply turtle and drag that into our project. So now we have just our individual turtle there. And then from there, we can form a group of turtles of kind of 3 of them side by side. So if we let's first create an empty game object. So we can right click, create empty. This is going to serve as like a parent game object. Let's position that on row 1. And let's drag our turtle into there. All right, so now we have this parent-child relationship. So if we move our parent, it's going to move the children with it. Let's have our turtle here. Let's duplicate this twice because we want 3 of them. And let's go ahead and position them so there's 1 to the left, 1 to the right. However, I want to have the one in front, so these turtles will be moving to the left. So I want the frontmost turtle to be at position 0, right? So that one will stay at 0, 0, 0. Then I'll take this one to be 1 to the right. And then now this one is 2 to the right. And so now we have got a little line of turtles. And this kind of forms a platform in a sense. So let's go ahead and just call this, I'm just going to call this turtle 3 to indicate there's 3 of them. And I'm going to make this itself a prefab. So I'm going to drag that into our prefabs folder. And now we actually have a prefab that contains other prefabs, which is totally valid. It's actually a somewhat new feature of Unity where you can actually have nested prefabs, which is something for the longest time Unity did not support. And it was really annoying, honestly, not to be able to have that feature. Okay, so we have turtle 3. There's our first one. Now we can go ahead and duplicate this and position a few of them. So let's have 4 of these. So let's go ahead and duplicate this a couple times. Let's position one at, let's say, -7. Then do, yes, -7. Let's do -2. And then let's do +2 and +7. And there we go. So there's a kind of a 2 space gap, a 1 space gap, another 2 space gap. When they start to cycle back and forth, that'll make a difference. Sometimes, like if we had these be all 2 spaced apart, then when they start to cycle, it might actually create a even larger gap, just depending on like how fast they cycle and so on. So I found that this kind of layout kind of works the best. So there's our turtles. We have one more set of turtles on, I think, a couple rows above. It'll be, so that's 1, 2, 3. So it'll be on row 4 here will be another set of turtles. But this time it'll just be a set of 2 turtles. So let's start with just a single one. Let's move it up to row 4. And then let's duplicate that. Well, actually first, let's create a new empty object. Reset the transform. Let's position it at row 4. We can parent our one turtle to it. Let's duplicate it. We're gonna have a second one. Once again, these are gonna be moving to the left. So I want the frontmost one to be at 0. And then the second one will position 1 behind. Now let's go ahead and turn this into a prefab. I'm gonna call this turtle 2 to indicate there's 2 of them. Just drag that into our project and there's turtle 2. So let's now duplicate this several times and line them up. So let's get 4 of those. And let's see, let's position these at -4, -4, 0, +4, and +8. So those ones will always be spaced out pretty evenly. And there's our turtles. All right, finally, let's go ahead and do our logs. So very similar to our turtles, although this one, you know, each log is going to be comprised of multiple sprites. So we'll see how that works. Let's just start with an empty game object here. We don't need a prefab for an individual log because there are sort of 3 different individual logs. So in that case, it's actually just going to make it more complicated. So we don't need an individual log. Let's just start with our group. So we're going to create an empty game object, but let's position this on row 2. And for row 2, these are going to be 3 log. They're going to be a total size of 3. So let's go ahead and drag in log start, log middle, and log end, and we're parenting all of these to our empty thing. I'm going to call this log 3. And then these are not, we need to fix the position got changed. So let's put all those at 2, or no, these should all be at 0. The children are at 0 because we have the group as a whole is parented. And then very similar to our turtles, we want the frontmost one to stay at 0. So, and our logs are going to go the opposite direction of the turtles. The logs will go to the right. So log start will stay at 0. The log middle, let's put that 1 behind. Log end will be 2 behind. And there's our little log there. So that looks good. I forgot to add our colliders to all of these though. So let's go ahead and add that. We can select all 3 of them at once, add our box collider 2D, mark them as trigger. And did we do that? Yeah, we did that. Yeah, see, that's for our turtles. Because we have a prefab just for the individual turtle, we only had to do it once for that turtle. We don't have to do it for the groups as a whole. All right, so there's log 3. We can turn this into a prefab. Boom. And let's position 4 of these on our screen. 1, 2, 3, 4. Let's give these, let's say -6, -6, -2, +2, or actually we're gonna separate them, so we'll do 3 and then 8. All right, there's those logs. Same process here. Let's go ahead and do our next row. This is going to be a total size of 5, so it's gonna be like or 6, sorry, it's gonna be like a 6 log fixture. Let's go ahead and start with an empty game object. Let's position this at row, what is it, row 4? No, 3, row 3. Let's add our start. We're gonna need, let's see, 3 middle pieces, 4 middle pieces actually. Yeah, there'll be 4 middle pieces, and then our end. So in total we have 6. 1, 2, 3, 4, 5, 6. Let's call this log 6. And I need to refix. When I drag them in here, it's setting their position to be -3. The children object should all be focused around 0, or at least in the Y. All right, and then let's go ahead and just continue to offset. So the starting one will stay at 0, and we'll just go down the line. -1, -2, -3, -4, and log end is now at -5. And there we go, there's our log 6. Let's add our colliders to all these. Box collider 2D, mark as trigger. And now let's turn this into a prefab. Log 6. Great, we're just gonna have a couple of these, so I'm gonna have 3 of these actually. And let's position one at -8. Position one at 0, and one at, I think, +8. Yeah, these will just be perfectly spaced out. Great, and we have one final set of logs here. So let's repeat this process one more time. And I'm running out of space here. Let me drag this down. Or let's just create I can't drag down in order to right click, so instead we can click the little plus button at the top. Create an empty child. This will be log 4. Reset its position. This will be at row 5. Let's give it our start. We need 2 middle pieces and an end piece for a total of 4. Let's set their positions all back to 0. And once again, -1, -2, and -3. All right, let's add our colliders. Box collider 2D, mark it as a trigger. And let's turn this into a prefab log 4. All right. Let's duplicate this a few times, and then we can call it a wrap on our scene. So we're gonna have 4 of these. 1, 2, 3, 4. Let's position one at -5. Let's do one at 0, one at +5, and one at 10. And there is our logs and our turtles. The only thing remaining are our homes. All right, let's do our homes next. I know this whole process is fairly tedious. I found when making this game that the most time-consuming part is just doing this scene setup. The actual code for the game is actually relatively straightforward, and there's really not a whole lot to the actual programming for it. So just kind of going through and setting up your scene can be a little bit tedious, but we're almost done. Let's go ahead and add our homes now. Now our homes are going to be a little bit of a unique object. There's going to be a couple different aspects to them. So let's just start by dragging one into our scene. And let's just position it for now. This will be row 6, although you can see it needs to be a little bit more raised up. There needs to be a little bit more of a space between, just because of the way the size of this object. Let's give it a little bit of an offset of like 0.25, and that'll be better. Now for our home, we're gonna have to have a few different components to this. So for one, we're gonna add our box collider just like normal. Now, but you can see by default, it sizes it all the way around the entire thing. We want just a collider in the middle here, because the Frogger is gonna have to jump just to the middle part. It will be a little bit platform, and then that indicates like this kind of safe spot that's kind of the win condition. Whereas if they jump into the walls, that's actually they lose, they die in that case. So we don't want the collider to be on the walls, and then what will happen is it's just gonna think it's the water. Basically, the collision will just treat that like water, which we'll get to later. But for now, we just want to change the size here. If we look at our box collider, we can adjust the size of this. So we can set this to, let's just say 1 by 1. All right, and that's actually perfect. So just set it back to 1 by 1, and we're good to go. Now we also want to add a little, when the Frogger does get home, we need to display another sprite inside here. So we have this home frog sprite. What we can do is we can drag this as a child of our home, and it positioned it once again at the wrong position. So let's set that back to 0. And let's adjust the size of this just so he kind of fits in the space. This doesn't have to be perfect, but I'm just going to kind of reduce the size a little bit. Let's say 0.75, and let's position him maybe at -0.2. That looks good. So he just kind of sits inside there. And I actually want this object to be turned off by default. All right, we want to turn this off because it will only display once Frogger has actually successfully gotten home. So we can just check the box in the inspector to disable the frog entirely. We will want a box collider on this too, because once Frogger has already went home, you can't go to the same one again. So this will then serve as an obstacle. So this itself needs its own trigger. So add the box collider trigger, but once again, for now, he's going to be turned off completely, and Encode will turn him on and off as needed. So this is a single home. This looks good. We can once again turn this into a prefab. That way, if we make changes in the future, it will apply to all of them at once. Let's go ahead and duplicate this. There should be 5 of them, and they should be able to just be positioned kind of perfectly. Oops. Oh, you know what? I think these overlap. So -2. That doesn't look right. Hold on, let me check real quick. That does not look right. Okay, yeah. So one will be at 0. This will be -2.5. There we go. Yep, that looks good. And then we'll have, I believe, -5. Yeah, perfect. And then the same thing on the other side. So +2.5 and +5. And then we've got our 5 homes. They all fit within our space. We can see, yeah, we haven't even looked from our game views perspective. Everything looks perfect. And once again, we talked about this earlier. We have that little bit of space at the very top of the screen that we can put some UI, which we'll get to later. But there is our home. So finally, we have completed all of our scene setup. I know that was kind of the most tedious, probably most time-consuming part of this whole video, but it's a necessary step in making our game. All right, let's go ahead and add Frogger to our scene and write our first script for his movement. Let's go ahead and go to our sprites. Let's take our Frogger idle and drag him into our scene. Switch to the scene view, drag him in. We'll position him right at the bottom. Position 0, 0, and the Y being -6 is our bottommost row. Now you notice he's behind our median. So let's change our order and layer so he always renders on top. So we set that to 1 in this case. We had our water and our road were in the negatives because they're sort of the background elements. Then everything else was at the default of 0. But Frogger, to make sure he's always on top, will be at 1 now. And let's go ahead and add our collider. Box collider 2D. Mark it as a trigger. And we also want to add a rigid body to Frogger. Now, normally what a rigid body does is it turns this object into a physics object, which means physics will actually be simulated on this object, you know, so things like gravity and mass and drag and so on. Now, we don't actually want to simulate physics on Frogger, so we can change the body type to kinematic. Now, you might be wondering, okay, why do we actually need a rigid body if we're not simulating physics? And that is because in order to detect collision between 2 objects, one of those objects, at least one of those objects needs to have a rigid body. The colliders themselves are not enough to detect collision. The collider is really just defining the shape of the collision area, but it itself is not really handling the collision itself. The collision is handled by the physics engine, and our rigid body component here is the bridge to the physics engine. So we need this to exist on at least one of the objects. And since collision will always be happening between Frogger and everything else, we can just add the rigid body to Frogger and we don't have to add it to anything else. So we just need to make sure it's set to kinematic. We also should check this use full kinematic context. You can see what this says is that should kinematic/kinematic and kinematic/static collisions be allowed. So if you had multiple kinematic objects, normally speaking, collisions wouldn't be handled by them. But in our case, we want to check that on to make sure that we are still handling collisions in those cases. And that's it for Frogger. I'm going to rename this to just be Frogger. And we don't actually really need a prefab for Frogger because we're just going to have a single instance of it. But if you'd like, you can make Frogger a prefab. Same thing, just drag it into your project. And let's see, what else do we need to set? I guess we don't need to set anything. We can go ahead and start writing our first script. Okay, so let's go ahead and first create a new folder called scripts. And let's go ahead and add our first script here. I'm going to right click, create C# script. I'm going to call this Frogger. And now we just need to drag this script onto our Frogger game object. So I've selected that game object. I'm dragging it into this empty space down here. And now this script will run on this game object. And we can click the little menu, edit script. Let's go ahead and begin coding this. So we're going to focus on Frogger's movement first. By default, Unity creates us a class here that inherits from mono behavior. And it gives us a couple functions already defined that are just very commonly used by Unity. I actually like to kind of remove everything and just start fresh. I remove these imports that aren't used, remove all the functions. That's just my personal preference. But starting fresh here, let's do a couple things to handle movement. So we need to check for input, player input, and then based on that input, we can change the transform of Frogger respectively. So to check for input, we need to add our update function. The update function is called every single frame this object is running, or the script is running on a game object. Every single frame. This gets called automatically by Unity. And this is usually where you're going to do your input. So we can, for example, say if input.get, oh, let me turn off my copilot so it doesn't get in the way. Okay. If input.getKeyDown is the function we can use to check a specific key on our keyboard. And we can say, for example, keycode maybe W. I'm going to use WASD. I'll do both. So I'll use WASD and the arrow keys. So we can say get key down W, or this means or input get key down keycode.up arrow. So we can check for both. And in this case, we should move up. To move up, we just change our position on our transform. So we access the transform and then the position property, and we can say plus equals vector3.up. Now, there's going to be, later on, there's going to be a number of things we need to do whenever we move. Like we need to check for collision on certain objects and, you know, things like that. So I'm going to actually create a new function simply called move. And I'm going to pass in the direction I want to move here. So it's going to be a parameter. It's going to be called direction. It's a vector3. All of our transform values are vector3. So for example, if I high over position, it's vector3, which is why I'm making this a vector3. And so we can just take this code, move it instead into here. But instead of saying plus equals up, it'll be plus equal whatever direction we pass in. Okay. And then later on, we're going to do a bunch of other stuff inside here. But now in our if statement, we can say move vector3.up. Right. So it kind of makes sense. It reads nicely. Let's go ahead and do the exact same thing for our other inputs. So we can do down S and down arrow. And he's going to instead move vector3.down. Oh, and this should be else if. So if you didn't press up, instead, let's check if we press down, and then same thing. Let's check if you press left and right. So let's do A for left and left arrow. This would be vector3.left. Let's do D for right as well as right arrow. And let's do vector3.right. Perfect. So that is our basic movement. Let's go ahead and test this out. Switch to our game views, play the game, and there we go. I can move around. Now, obviously nothing else is moving. I can also float on water and do a bunch of things I shouldn't be able to do. It's because we're not really checking for collision or doing anything yet, but we at least have some basic movement in place. One thing we can do really quick though is make sure we rotate Frogger based on the direction you're moving. So let's go back to our code here. And we need to add one more thing when we do this. We can actually pass in another parameter here. So let's have a second parameter. This will be called, actually I won't do it as part of this. Because it's not really move related. You're not really moving. So let's keep it out of that function. And instead we'll just do it within our if statement. So to set the rotation, it's kind of the same thing. We're going to say transform, but instead of position, we're going to say rotation. And rotations are represented by something called a quaternion, which is a kind of complicated mathematical way of representing rotations. It would be way too much work to explain how quaternions work. But for our purposes, we can create a quaternion and set it to a specific angle using quaternion.Euler. This is the more kind of rotation you might be familiar with, where, for example, in the editor, if we go to our rotation, this is, 90 degrees in this axis, or, we can change these values here, and these are actually Euler angles, not quaternions. So when you're actually changing things in the editor, that's kind of what you're familiar with. So let's just imagine we need to pass in an X, a Y, and our Z. It would be exactly what we would want to set Frogger to if we were to do it in the editor. So for example, if I wanted to rotate Frogger to the right, what would I need to change in the rotation? If I change the Z, now I can rotate him, right? So we know, like, if he's facing to the left, his Z would be 90. If he's facing to the right, it would be -90. And if he's facing down, it would be 180. So we just have to match that in the code. So here for up, and then for up, it'll just be 0. So we can just set everything to 0. Let's copy this line of code. For down, we said it should be 180. And this is only in the Z. The X and the Y can stay at 0. For left, I don't remember if it was positive or negative. Let's try positive. And then for the right, let's do -90. Let's go ahead and test that out. Let it recompile, play the game. Yep, and there we go. And there we got it all right. So we can actually face the direction we're moving now, which is perfect. So there's our basic movement. All right, now let's go ahead and give Frogger a little bit of an animation when we move. We don't want him to just instantly kind of jump from one spot to the other. We want to animate his change in position. So we're going to use a little bit of a somewhat advanced concept in Unity called coroutines. So I'll kind of explain as I go, but within our move function here, we don't want to just instantly change the position. Let's comment that out for now. And instead, we want to start a coroutine that's going to change this position value over time. To start a coroutine, we need to create one. But eventually, so to start a coroutine, we have to call start coroutine, and we need to actually pass in another function that is the coroutine itself. And a coroutine is essentially a way of running another set of code outside of the update loop. So to actually define a coroutine, we actually need to import something. So let's go ahead and import using system.collections. And then let's define a function for our coroutine. And we need the return type of this function to be IEnumerator. And then we'll give our function a name. I'm going to just call this like leap. And then if we want, we can pass in parameters, which we actually should. We should pass in like what's the destination that he should leap to, right? So you're leaping to some destination. And then in here, we can do our code. To start, let's finish our line of code up here. So start coroutine, we're going to call leap, and then we're good to go. And then we need to pass in our destination. So let's calculate our destination. It's going to be destination equals our position. It's really the same code here, but instead of saying plus equals, it's just going to be plus. So transform.position plus direction. That gives us our new position, our destination. We can pass that into our leap function. So here we now have a coroutine. And so within a coroutine, we're going to be using a yield statement, which will kind of pause the execution of this until a later time. And that's how we can then do something over time. So when doing anything over time, we need to keep track of how much time has elapsed and then get a percentage over the duration. So let's say we want to animate something over 1 second. We need to know how much time has elapsed, and then figure out the percentage. So let's say 0.5 seconds have elapsed and it's a 1 second duration. Well, that means 50%, we're 50% through the animation. And then we know our position should be 50% from, 50% from the start to the end. So let's define those variables. Our elapsed time here will start at 0. Our duration can be whatever. For our leap animation, we want it to be pretty fast. So let's do maybe like 1/8 of a second, which is 0.125, I believe. And then we can set up a loop here. We can say while our elapsed is less than our duration. So in other words, while our animation has not finished, we have not exceeded the entire duration yet, we're going to do some stuff, and then we're going to repeat this over and over. What we're going to do is change our position. So we can say transform that position equals, and then Unity has some built-in functions that allow us to sort of interpolate from one position to another position, and then given some percentage. And so the way we do this is vector3.lerp linearly interpolates between 2 points, lerp, and then we have to pass in A and B. So this is kind of our start and our end. And then T is like the percentage basically. So we don't know what A is. We do know what B is, and that's our destination. And then we can figure out our T by calculating T equals elapsed divided by duration. This gives us our percentage. So we can pass that in. And then what is our A here, our start position? Well, we should store that in a variable before we execute our while loop, so we know what its initial position was before we make any changes. Because as soon as we make a change, we're not going to know what the initial position was. So we want to store this first. It'll be the first thing we do. So we're going to grab our current position, store that into a variable, and that becomes our start position. So we're lerping between our start and our end with the percentage of time here, which is based on elapsed and our duration. Then this is where we yield. So we're going to say yield, and there are different ways you can yield. In our case, we don't need to do anything fancy, so we can just yield return null. And this is going to say, okay, pause the execution of this coroutine and wait until the next frame. So this will pick back up again the very next frame. And this is where like you could, for example, like yield for like X amount of seconds, but in our case, we need to update the position every single frame. So we kind of just say, wait till the next frame, then we'll do the whole thing again. Now what's missing here is our elapsed time isn't changing. So we need to increase that. Every time we change our position, or every time this loop runs, we need to update how much time is elapsed. So we'll say elapsed plus equals, and then Unity keeps track of how much time has passed from frame to frame in the time class. We can say time.delta time. This is indicating how much time has passed since the last frame to the current one. And there we go. So there's our kind of basic animation for changing our position. Now, to guarantee that Frogger ends up at the exact desired destination, once the whole while loop is done, this means we've completed the animation, or at least the elapsed has exceeded how long we wanted it to be. And just to guarantee that he's in the exact right position, we can set our transform position to be that destination. Just one last time, we'll just directly assign it, and we're good to go there. So let's go ahead and test this out. Let's play our game. Yeah, so now you can see as I move, it might be fairly subtle because it's a pretty quick animation, but there's actually kind of an animation from one position to the next. I don't just instantly kind of teleport to that next position. So it feels a little bit better. What we need to do to improve this though is change the sprite so it looks like we're actually jumping. And so we do have another sprite in our project that is Frogger Leap. So while we're doing that animation, we want to change the sprite to this one instead. So let's go ahead and figure out how we can do that. Let's open back up our script. And to change the sprite, we need a reference to our sprite renderer, so we can then assign the sprite that is being rendered. So let's create a variable to store our sprite renderer. And usually in Unity, when you want to establish references to other components, you usually do this in awake. So awake is another function Unity calls automatically. In this case, it basically is going to be called as soon as this object is created. As soon as this script is initialized for the first time, this will get called. And this is where we can establish some references to other components. So So we can say sprite render equals get component, which is a function Unity provides for getting another component. And it'll get the component on the same game object you're calling this on. Right, so we know in Unity here, here's our Frogger game object. We can get any of these other components that exist on Frogger. The rigid body, the box collider, the sprite renderer. We want the sprite renderer because that's where the sprite property exists, and that's what we want to change. So let's go back. Let's get component, sprite, renderer, call that function, and there we now have a reference to our sprite renderer, and so we can set what the sprite is. Let me go ahead and get rid of that line of code. We don't need that anymore. So when our leap animation starts, we should update our sprite renderer. So we can say sprite renderer.sprite equals something. And then same thing when it ends, we will set it back to the default. So we need to replace these question marks with something. So once again, we need a reference to the sprite asset we want to assign for each of these. So we can create references here. These ones we're going to make public, and you'll see why in a minute. Let's say sprite, and we'll call one the idle sprite, and we'll call one the, let's say, leap sprite. Okay, so now when we start our leap animation, we should set our sprite to be the leap sprite. And when we finish our leap animation, we should set our sprite back to the idle sprite. And there we go. Now, the reason we made those variables public is because they will show up here in the editor. Notice how the other variable for our sprite renderer doesn't show up because it's private. These ones are public, so they will show up here. And now we can assign the references directly. So we can access our sprites here and find, click back on Frogger, assign our idle sprite. So we can just drag those in, drag in our leap one. We can also click this little circle menu. That's another maybe easier way to do it. So we have assigned those. Let's go ahead and run this and see what happens. Yeah. So now when I actually jump, you can see his sprite is changing, and that sells the illusion of Frogger actually leaping from position to position. So that works actually really well. All right, now let's focus on the movement of our various objects, our turtles, our logs, our cars. All of these objects will run off of the exact same script. So let's go ahead and add a brand new script. Let's maybe just call this like move cycle, because they're going to cycle from one side of the screen to the other. We're not going to create new game objects every time. You know, some games might say, okay, as soon as they go off screen, destroy the object and then spawn a new one on the other side. That's a waste of resources. We can instead just move it from one side to the other as soon as it's off screen. So we're going to call this move cycle. Let's go ahead and edit this. And there's a few things we need to do. I'm going to delete everything just like I normally do. So considering this is going to be used for every one of our objects, the logs, the turtles, the cars, there are a few differences between these. The differences are which direction does it move and how fast does it move. So we should create some variables. We should create two variables for those things so we can customize it per object. And these will, once again, they'll be public. That way they show up in the editor and we can change those values for each individual object. So let's create a vector2 to indicate direction. And maybe I'll just default it to right. Doesn't really matter. And let's add a variable for speed. And this will just be a float. And maybe I'll just default it to 1 to kind of just be a kind of neutral setting. The other thing that's going to play a role here is the size of the object. Because we need to calculate when the object is out of the screen, out of the bounds of the screen. And that's going to vary based on the size of the object. So we should have a variable for size, because that's going to change between different objects. This will be an integer. We'll default it to 1. Most of our cars are size 1. I think these are like trucks are size 2. You know, our turtles size 3. There's also size 2, 3, 5, 4, right? So different objects are different sizes. All right, so I've already kind of explained our goal, which is to detect when the object is completely past the bounds of the screen. And when that happens, then we need to bring them back to the other side. So in order to know when an object is past the bounds of the screen, we need to convert the screen coordinates into actual world coordinates. Right, so we're going to compare the position of our objects to something, and the position of an object is in world coordinates, but our screen is in its own coordinate space. So we need to make sure these two things are in the same coordinate space so we can compare them to one another. So Unity provides us some functions to convert screen space to world space. And actually first, let's create some variables to store these values. So I'm going to create two vector3s. I'm going to call one left edge and call one right edge. And then we'll say in our start function, we can calculate what those should be. We only need to calculate them once. And so I don't want to calculate these and update every single frame because they're not going to change. We can just do it in start. And once start is another function Unity calls automatically the very first frame this script runs. So for our left edge, the way we can convert this is by accessing our camera, and the camera has functions that can convert to world space. So we can say camera.main. This is going to get the first camera in our scene that is marked as main camera here under tag, which by default, the default scene that Unity provides to us already has all that done. So we didn't have to do that ourselves. Camera main, and then we can say viewport to world point. And I guess I somewhat misspoke where we're not actually converting from screen space to world space. It's more so like converting viewport to world, exactly what it says, viewport to world point. And we need to give the position of our viewport and it will return the world point. So the left edge of our screen is just 0. It's just 0. And it's basically 0 on the left and 1 on the right. And then I believe it's 0 on the bottom and 1 on the top. So essentially the bottom left corner is 0, 0. And then the top right is 1, 1. Actually, that's not true. The top right, I believe that is true actually. So 0, 0, and then 1, 1 in the top right. So that's our left edge. For our right edge, same thing. Viewport to world point. But this time we want the right edge. So once again, I said it would be a value of 1, 0 on the left, 1 on the right. So we can just say vector3.right, which is just a shorthand way for saying 1 in the x-axis. So vector3.right. It's a little unintuitive. You would think it'd be vector3.left and vector3.right for left edge and right edge, but no, because this is -1 and +1, whereas our viewport is from 0 to 1, not from -1 to +1. So that's something that I have gotten a comment on when I did Space Invaders. People were a little bit confused about that as well. All right, so now that we have these positions, now we can compare the position of our object to these to know when they are past the edge. So in our update function, every single frame, we need to either move the object or change it to the other side if it's past the bounds. So to check if it's past the bounds, let's check on the right edge. So if and this is going to vary where based on the direction it's moving, we only need to check if it's going on the right edge if it's moving to the right. So to know if it's moving to the right, we check to see if our direction x is greater than 0. That means it's moving to the right. If it's less than 0, that'll indicate it's moving to the left. So if it's greater than 0, it's moving to the right. Therefore, we should check the right edge. Okay, so it's moving to the right, and then we can get its position. So something in here is greater than the right edge, right? So we need to get its position here. Transform.position.x. But there's more to it than just that. Because so our logs are moving to the right. So the 0, 0 of one of these logs is this object here. You can see the little, it's very faint, but this little circle is our pivot point. So this is 0, 0 is this edge. As soon as that object is on the edge, well, it's actually not out of bounds yet. The entire thing needs to be out of bounds. So that's why we need to know how big this object is. We need to know the size of it so we can say basically this position minus whatever the size is. So this position minus, 3 in this case. Then if that point is past the bounds, well, now we know for sure the entire object is out of bounds. So this will be position.x minus whatever our size is. And if that is greater than our right edge, well, now we know for sure that this object is out of bounds. So what happens if it is out of bounds? Well, let's set its position to be all the way on the left side now. So we can set its position here to be a new vector 3. And we really only need to change the x. So actually, let's maybe do this a little bit differently. Let's do this where we get its current position. And we're just going to change the x value here. So position.x equals left edge.x. All right, so we passed the right edge. We're going to bring it back to the left edge. But once again, we need to offset this a little bit so it actually is fully spawns out of bounds and not partially out of bounds because of the size of it. So we're going to offset this the same way. We're going to say left edge.x minus the size. And then let's set this back onto the transform. Okay, now pretty much the same thing on the opposite side. So we'll duplicate all that code. This will be else if the direction is less than 0, to indicate we're moving to the left. Now we check the position, but instead of minusing, we should plus. And instead of checking the right edge, we should check the left edge. And now in this case, it's not greater than, it's less than. And then here, we're setting our position. Now instead, it won't be the left edge, it's going to be the right edge. And instead of minusing, we're going to plus. Okay. Now, if it's not out of bounds, so if it's not past the left bounds, it's not past the right bounds, well, then that means it's just in the middle of the screen somewhere, and we should just move it like normal. So in our else case, we can just say transform dot translate. And here we can say, how much do we want to move this object by? Well, our direction. We want to move it by our direction times the speed for however fast it's moving. And we want to factor in delta time, which will make sure that based on the frame rate of our game, it's not going to vary. So like if my computer runs really fast and your computer runs really slow, we don't want the object to, move really fast for me and really slow for you. It should, regardless of how good my computer is versus your computer, the object should move at the same speed. Right, so by factoring delta time, this is making sure that this movement is frame rate independent. Let's go ahead and test this code out. I know that was kind of a lot. It's definitely one of the more complicated aspects to this, but it's actually a fairly short script. There's only a few lines of code. And now once again, we can apply this to everything. And this is where our prefabs will come in handy. Instead of having to go through each individual object one by one, I can just apply it to the prefabs. So let's start with car 1. We'll drag that on to car 1. Car 1 moves to the left, so set our direction to be -1. And our speed, let me double check what our speed should be. They don't really matter, so I mean, feel free to set them to be whatever you'd like. But for this, I'm going to have this car be speed 2. Size is 1, that's good. Okay, next car, car 2, let's add our move cycle. For car 2, this one's moving to the right, so +1. These will be moving, these are a little tractor things, so these will move slower, so the default speed of 1 is good. Size is 1. Car 3, let's go ahead and add our scripts. This will move at the same speed as this one, so, and it moves to the left, so -1 with the speed of 2. Now for car 4, move cycle. These are the really fast ones, And they're moving to the right. So did I set? Yeah, -1. Yeah, so +1 to go to the right. These ones will be really fast. Let's set the speed to 3. Size is 1, good. Car 5, move cycle. And these will be moving slow because they're like big trucks. So just kind of base speed of 1. The size is 2 though for this one. And it's moving to the left, so it should be -1. And once again, feel free to like customize this. This is where you can get creative and change these settings to kind of adjust how your game plays. And in the real game of Frogger, I believe these settings will sort of change from level to level. So they might start out pretty slow, and then over time, they will get faster and faster. We're not going to go that in depth for this tutorial, but we have the variables here that we can change and customize. So that's how you would do that if you wanted to. It's just a matter of changing these values. All right, so those are cars. Let's do the same thing for our turtles and logs. So log 3, let's add, and we're adding it to the group as a whole. So move cycle, our logs all move to the right. So direction 1. Let me see what these should be. So for log 3, these will be moving at a speed of 1. The size is 3 because it's log 3. Log 4, let's add it there. Size is 4. Direction is 1. Speed will be, let's see. Speed will be 2 for this one. Log 6, move cycle, size is 6. Direction is 1 to go to the right. The speed for this one will be 3. These ones will be moving really fast. And then finally for our turtles, move cycle for turtle 2, size is 2. These guys will always move to the left, so -1. And then for the speed, I'll have that one as 1. And then finally turtle 3, move cycle, size is 3. Speed or direction is -1 to go to the left, and the speed will be 3. These ones will be fast as well. All right, that was a lot. Once again, pretty tedious, but it made a lot less tedious by having the prefabs. Let's run it. There you go. Everything's moving. Let's actually look from the scene perspective so we can see. Yeah, so you can see as soon as an object goes out of bounds, boom, it spawns back on the other side. And so now things will cycle. It'll just cycle forever, and our game will just go on. And from the perspective of the actual game, it looks very organic. You don't even necessarily realize that it's the same objects just repeating back and forth, Now, of course, we don't have the collision, so I can still, run past everything, but we're getting there. This is good progress. All right, next up, we need to handle collision detection. And there are really 3 different types of collision detection we're going to do. Well, not really types, but there are sort of 3 distinct things we need to handle. One is the collision between obstacles, or the things that will actually kill Frogger. Then there is the collision on the platforms that you will ride on top of and move with, so our logs and our turtles. And then there's also barriers that will prevent you from moving entirely, which is mostly just for preventing you from going out of bounds. So maybe let's start with that one because that'll probably be the easiest. So first of all, we should add some barriers, some invisible barriers on the sides just to prevent you from going out of bounds. So I'm going to add a brand new empty object to our scene. I'm just going to call this barrier. Let's reset its position or its transform. Let's add a box collider and set it as a trigger. We can see it in the middle. I'm going to position this on the left, and this should be right on the edge of our camera here. It doesn't really have to be perfect, so as long as it's good enough, let's scale it up so it fits the entire thing. So 16. Good. Let's duplicate that and move it to the other side. Good. So now we have 2 barriers on the left and right. And in order to detect collision between these 3 different types individually, we're going to want to create layers for each of them. So let's go ahead and add layers. This will make more sense in a minute once we add the code, but we're going to need all of these objects to be on their own layers. So let's add a layer for our platform, for obstacle, and for barrier. Let's go ahead and assign these layers to all of our objects. So barrier for those 2. And then let's go to our prefabs. We can select all of our cars. Let's set them to be obstacle. Let's set our logs and turtles to be platform. So select all those, platform. This will ask if you want to change the layer on all the children object as well. We can say yes for that. And so we set our layer for all of these. The layers will allow us to detect collision independently from other layers. So we can then handle what happens differently based on which layer the object is on. So in our code, let's go to our Frogger script, and this is where we're going to start adding more to this move function. So for barriers, for example, we don't want to move at all if you run into a barrier, right? So we want to not call these things if you run into a barrier. So how can we determine that? Well, we can check, knowing the position we're going to go to, we know our destination. We can check if there's an object at that destination that is a barrier. And if it is, well, then we shouldn't go there. We should just not do anything. Prevent movement entirely. So how can we check if an object exists at this destination? We can access Unity's Physics 2D class. So Physics 2D, and we can say overlap box. This is going to return the collider that exists at a given position. So I can pass in my destination there. Now we need a size parameter, which is indicating like how big do you want this box to be. In our case, we actually can just set this to 0. We kind of just want the exact point that we're providing at this destination. So we can just say 0 basically. And then our angle, this is like if you wanted to have the box be rotated. We don't care about that, so we can set that to be 0 as well. And then here, this is where the important part comes in. We can provide a layer mask. So this is going to say only check for collision on this specific layer. So we can create a layer mask saying layer mask, get mask, and then we can give the name of the name of the layer we want to look for. So in this case is barrier. All right, so this is going to return a collider if it exists. So we'll call that barrier. So if this barrier exists, well, then there's a barrier there and we should prevent movement. So we can say if the barrier is not null, so it detected there is indeed a barrier at this destination. Well, if there is, we should just return. We're just returning out of this function. We will not execute anything that comes after this. So we're not going to do our leap. We're not going to call our leap, which is going to change our position. We're just going to stop right in our tracks. Let's go ahead and test this out. Let that recompile. Play the game. And I can just, so look, I can go all the way on the left edge and I can't move any further. It doesn't allow me to. Same thing on the right edge. Can't move any further because the barrier's there. So there, we're good there. There's our barrier. So now let's go ahead and do our platforms for our moving objects. So it's going to be very similar, kind of, in that we want to do the same exact function call we did, but instead, we're going to look for a platform. So we'll change that from barrier to platform. We'll call this one platform. We're checking, once again, the destination, the position we're trying to move to see if there's a platform at that position. And when Frogger goes onto any of these platforms, Frogger needs to move with the platform. The easiest way to do that is to simply parent Frogger to that object. Because then, if that object is moving, Frogger automatically moves with it. That's just how parent-child relationships work with transforms. So we can say if platform is not null, well then we know a platform exists at the destination and we should parent Frogger to it. So we can say transform set parent, and we're going to parent it to the platform dot transform. And if the platform does not exist at that location, we should make sure we're deparenting it. So we can set this to null. That way, if we're currently on a platform and we jump off of the platform, so there's no longer going to be a platform at our new destination. We should make sure we're detaching ourselves from it. Let's go ahead and test that out. So in theory, when I jump onto any of these objects, I should be able to just ride with it. There we go. Yep. Rides with it. Same thing with our logs. Perfect. Now, one thing we can see here is I actually can go out of bounds because we're only checking for the barriers if I try to move out of bounds. But notice how I came back because these objects cycle. So for me, I actually kind of like this. I actually think it's kind of cool that you can kind of cycle back to the other side. I think the original game, it doesn't allow you to do that. But for our cases here, I'm going to allow it. I kind of like it. So that's actually it for our platforms. We don't need to change anything else. Okay, and finally now we have our obstacles. The obstacles we save for last because it's sort of the most involved. But we're going to kind of do the same thing. Let's check instead now for an obstacle. Let's call this obstacle. And for our obstacle, well, you know, Frogger needs to die in that case. So we can say if obstacle does not equal null, then we need to, you know, do something. We need Frogger to die. Now, we're not going to implement the full death thing quite yet, but let's at least add a function to indicate that Frogger has died here. And we'll come back to this later. But we can call that if we move onto an obstacle, then Frogger indeed dies. If Frogger does not hit an obstacle, well, then this is where we can go ahead and do our movement. Now, if you do, we're checking the destination to see if an obstacle exists there. We should still move Frogger to that position, even though, you know, they're going to die, but we should still set the transform position to be the destination. Because later on, we're going to add a little, you know, we're going to change the sprite that shows up when you actually hit. Actually, we can just do it now. Might as well. Let's go ahead and add a new sprite here. And we'll call this like dead sprite. All right. So when you die, we're going to set the transform to be that destination. We're not going to animate it. We're just going to instantly set it. And then we're going to swap out the sprite. We'll swap out the sprite in our death function here. So just like we did in other places, we can just say sprite render sprite equals dead sprite. And then to disable control, you know, when you're dead, you shouldn't be able to control Frogger anymore. So we can just turn off this behavior. Enabled equals false. And then for this sprite in particular, we want it to always be rotated kind of, you know, or not really. We don't want it to ever be rotated. So because Frogger's rotation changes based on your movement, we can just reset our rotation. And we can just say quaternion.identity is kind of the easiest way to just reset rotation back. Basically, identity is like 0, essentially. So let's go ahead and test this out. And we need to assign this sprite here that we just added. So let's go ahead and assign this. Let's do Frogger dead. Let's play this. So if I step here, now notice how it doesn't detect collision. We'll come back to that. But if I run into it myself, it does. Because once again, this code we just added is only checking for collision when I move. So if I'm not moving at all, we're not checking for collision. But if I run into it, we're good there. So let's fix this problem here. Not only do we want to check for collision when we actually move, we need to check for it sort of all the time because the cars themselves are moving. And Unity provides a function that will tell us when something has collided with an object. So we can say, add a function here for on trigger enter 2D. This takes a parameter here called collider 2D, which is the other collider that you collided with. So remember how we've marked all of our colliders as triggers? So this is saying some other collider has entered our like trigger zone, and therefore this function gets called. So we can say, well, what was this other object that we collided with? Was it an obstacle? And if it was, well, then we should call our death function. So we can check. We can say if the, well, here, let's do this. We'll put this in a Boolean. We'll say if we hit an obstacle equals other, you know what? No, let's just do an if. If the other game object layer equals basically our obstacle layer, then yes, we hit an obstacle and not something else. We can't just put a string here, unfortunately, because these aren't strings, they're actually integers. So we need to say layer mask got name to layer, and then we can say obstacle. So basically this is saying if we hit an obstacle, well, same thing, we need to call our death function. And to make sure this doesn't happen multiple times, like if you're already dead and then another car hits you again, we should make sure that our script is enabled. So if our script is enabled, if Frogger is basically like active and enabled, and we hit an obstacle, then it should be dead. And that is good. So let's test this. Let's run it. And oh, so notice that I instantly died there. And that's because there's already an overlap between our colliders. And so this is something we should adjust. So notice the Frogger's collider is this green outline. It's way bigger than his actual sprite. And so it's technically already overlapping with this car here. Just on that little tiny corner. It's technically overlapping, so they're considered colliding with one another. What we can do to make this collision a little bit more accurate is just to change the size of Frogger's collision box. I'm just going to make this a lot smaller. I'm going to do a quarter of the size. So it's just going to be basically his little body. This will give him a little bit more space to kind of make really tight maneuvers around cars, and just make it feel a little bit better. So let's set that. Let's try this out. I shouldn't instantly die this time. Good. So I'm not instantly dying. I can sit here and boom, now it detects that I've died. All right, now there's one more thing we haven't accounted for, which is that I can jump into the water and nothing happens because we haven't marked our water as being an obstacle. And this actually presents a new problem you'll see in a moment. But first, let's go ahead and mark our water as an obstacle. It's one of the objects we forgot. So water, layer, obstacle. Let's play it again. And this is going to cause a problem, which you'll see in a moment. If I jump onto the turtles here, oh, it actually worked fine. Wait, I thought that was going to cause an issue. Hold on, okay, never mind. So I can still jump in the water, and that's because our water does not have a box collider. So we need to add a box collider to our water. And yeah, we do need to adjust the size of this a little bit because you can see the edge of the box collider is like halfway in the median. That means if I'm standing on the median, I would still be considered colliding with the water, which is not true right? So we should adjust this. So it's not quite, we can just do 0.75. And so then I'm good. I have to like fully leap at least one row before it starts to recognize that as water. All right, let's try. Oh, and I didn't mark this as a trigger. Okay, let's try it one more time. And once again, there still is going to be an issue with this that you'll see in a moment. So I can jump. Okay, so notice that like I was standing on the turtles, but I still died. Like I should have been safe there. Yeah, so like I'm jumping on the turtles, but I'm still dying. And that's because I'm both on the platform and I'm detecting collision both on the platform and on the obstacle at the same time. So we need to account for this in our code, which is basically to say if the obstacle is not null, we need to do an additional check first. If the obstacle is not null and the platform is null, right? Because if the platform's not null, then I'm good. I'm standing on like the turtle or log. I'm also on the water technically, but I don't want to consider that death because I'm kind of in this safe platform. I'm on top of the platform. So only if our obstacle, we hit an obstacle, but we're not currently standing on a platform. So you just dove right into the water, no platform. Then yes, that means you have actually, sunk in the water. And we need to do the same thing down here as well. So if our script is enabled, we hit an obstacle and our parent, we don't have access to the same platform data up here. But we know if we're on a platform if our parent is not null. Or in this case, we want to check if it is null, that means we're not on a platform. Therefore, we're not in like a safe zone per se. So we've hit an obstacle. We're not on a platform. Well, that means you've basically jumped into the water. So let's go ahead and test this out. Now I should be able to jump on these without dying. There we go. That works way better. And now if I like jump to the right, yeah, then I die because then I just fully go into the water. And let me just run once. Oops. Let me run once more and just kind of skip over everything and see what happens. Yep. So I can jump from thing. Notice here, I jumped into the wall. That's actually what's supposed to happen based on the original game. And this is where there's no collider or anything on that part of the home base. So it just thinks I'm hitting the water, which works out. I don't have to do anything special, but it just works how it's supposed to. Now, I don't remember if we did this, but let's check. When I jump actually into the little home spot, I should be safe. We should consider that to be a platform. Yeah, so like it still killed me, but it shouldn't. And that's because we should mark that little spot as like basically an invisible platform. We should be able to move to that spot and be safe. So if we go to our home prefab, if you remember, we added this collider here, which is just this little square. This we should indicate is a platform. Let's change the layer to be a platform. And no, I don't want to change the children on this, and I'll explain why in a minute. Oh, and I never marked this as a trigger. So mark that as a trigger, set its layer to be a platform. It's invisible. There's nothing to see, but I'll be able to jump there and safely kind of enter in the home. For the frog here, once you do that, then the frog will show up. But then you can't go to the same home again. So this is where the frog, it's kind of weird, but we're going to actually consider this an obstacle. That way, if you try to go to the same one again, you will actually die. It's already occupied. You can't jump to that spot. So we're just going to consider that an obstacle. And there we go. So it's really flexible that we can basically just mark any object as an obstacle or as a platform, and that's just going to change kind of how we can interact with that object. Oh, and I notice how they're all there because I turned that object back on and I never turned it off. So let's make sure that's turned off by default. Okay, let's test that out. I should be able to jump to that little sort of invisible platform and not die. Yep, perfect. And we'll get to scripting that in a little bit. So there we go. That is all of our collision detection. All right, let's go ahead and check when Frogger has entered one of these homes and actually properly enable the little frog that sits in there to indicate that you've occupied that home. Let's add a new script called home. And let's add this script to our home prefab. Drag that on here. I'm going to drag it to the empty space. And let's go ahead and edit this. And for our home here, we need to check when Frogger has entered. And when it has, we will turn on the frog. We'll display that little frog guy who's sitting there. So delete everything like I usually do. We're going to use that same function that we did in Frogger, this on trigger enter 2D. So actually, I'll just go ahead and copy that. And so this, once again, this function is telling us that something has collided with this object. You've entered the trigger zone. Some other collider has entered your trigger zone. In this case, the home. So we need to first check what that object is. because it could be anything. So we should check what this object is. And in this case, we only want to know if it's Frogger himself. There's a couple ways we can do this. Perhaps one of the easiest ways is to just change the tag on our Frogger game object here. So we select Frogger. Let's change his tag to just be player, which makes sense anyways. Frogger is the player, so that's kind of an easy way we can determine. And now all we need to do is say if other.tag equals player. Well, then we know it was Frogger that collided with the home base, which is good. Now we know, okay, this thing should, show the little frog guy. To actually be able to turn that object on and off, we should get a reference to it. So I'm just going to call this frog. And in this case, frog is not referring to Frogger. It's referring to the frog that sits inside the home. If I don't know, I don't have a better name for it. And in which case we could just say frog set active to true. But if we think ahead a little bit, we're gonna need to eventually turn this off as well. So let's set up our code a little bit differently to handle this easier. In my opinion, I think the easiest way we can do this is to think of our home prefab as being on or off. So when the home behavior is enabled, that means it's occupied. And when it's not enabled, that means it's not occupied. And so Unity provides us functions for this very thing. Unity provides us a function that is on enable and on disable. And so I think it makes sense to say, well, when the home is enabled, and kind of in other words, when home is occupied, we will set our frog to be active. And when it's disabled, it's no longer occupied, we'll set our frog to be deactivated. And then so here, when you enter the trigger zone, we just say enabled equals true. And this is something that's important, where certain functions aren't called when a behavior is disabled. So for example, if you remember in our Frogger script, we turned off Frogger when you die, so you then can no longer control your Frogger. You shouldn't be able to move if you're dead, right? So update is a function that does not get called when this behavior is disabled. However, on trigger enter 2D will still get called even if your behavior isn't disabled. So this still works out, and in our case, that's what we want. So we're good there. Let's go ahead and just test this out. Oh, we need to assign a reference to our little frog here. So once again, I'm within the prefab. I've added our home script, and now I can drag a reference to that there. Let's go ahead and play our game. See what happens. Oh, I did this thing again where so yeah, see, there's a problem here. I thought I did the thing where I turned it on and then I forgot to turn it off again. But no, they are turned off. And as soon as I play the game, all of a sudden they all show up, which indicates that our on enable is getting called, which is why, if the frog is getting activated, then this must be called somewhere, somehow. And well, that's because it is I never disabled the home script. So our home script should be disabled by default to indicate it's not occupied. And once again, we're doing this on the prefab, so it applies to all of them at once. There we go. So now they're not occupied. If I run over to one, and there it shows up. Now I can, we haven't, at which point we would then want to reset Frogger back to the beginning. We're going to get to that in a minute, but this is working. And I hit the wall, so I died on that third one, but that's good. But the next step is going to be a big one where we need to add our entire game state. So let's go ahead and focus on that next. Actually, before we start with our overall game state, let's actually focus on getting Frogger to respawn, and then we'll tie that into our overall kind of game state, and we'll create a game manager and so on. But first, let's add a respawn function to our Frogger script here. So I'm going to add this right below our death function. We'll have one for respawn. And respawn is kind of the opposite of death. So some of the things we do when we die, we need to kind of reverse. So for example, we turn off Frogger, so you no longer have control. but when we respawn, we want to turn that back on. Of course, we should set our sprite back to the default. So instead of being the dead sprite, you'll now be your kind of default idle sprite. Just in case, we should make sure we are setting the rotation back to identity, because there are cases where you can respawn without dying. So to make sure you always respawn back at the normal starting spot, we should do that. We also need to, put Frogger back at the starting position there. So we need to keep track of what that is. We can actually add that as a variable here. I could hard code it, but that's usually not a good thing to do. So instead, we can have a variable here. We'll call this our spawn position. And we can set our spawn position to be whatever our initial position is when our script awakes. So by default in our scene, Frogger starts down there. So right away, that's going to get saved into this variable. And so now when we respawn, we can set our position back to that spawn position. Okay, is there anything else we need to do? One thing I actually just realized that we didn't do when you die is we need to stop all coroutines. Because if you are currently leaping and then you die, this is still going to run even though we turn off the behavior. So we should stop all coroutines when you die. And same thing when you respawn, just in case, because once again, you can respawn without dying. So if you reach home, you're going to respawn, and to reach home, you're going to leap there. So it's going to be playing that coroutine, and then you respawn. We want to make sure it gets stopped. So you restart or respawn kind of at a neutral idle state. So we stop all coroutines in both cases. I think we're good there. Now we just need to call our respawn function in a couple of different places. So one, we should respawn when we die. So after you die, we should respawn. Now, you might be thinking like, okay, we do all these things and then we immediately respawn and basically just undo all of these things. And that's true. What we should do is we should delay the respawn by like a second or two, just to give a little bit of a buffer period. So we can do this very easily in Unity using this invoke function that they provide. And we can invoke some other method. We have to provide the name of it. So we can say name of respawn. And then we can say, how long do you want to wait? So we can say maybe 1 second. So basically there's a 1 second delay or buffer between you dying and then respawning. And then the other place you should respawn is when you reach home here. So in our home script, we know that this tag is the player. However, in order to actually call this function, we need access to the Frogger script. So we can get this using get component. And we're getting get component on other. Because if we get component not on other, it's going to try to get the component on the home. Frogger is not on the home. Frogger is this other object we've collided with. So we get it on other, and then we can say Frogger dot respawn. I can't access it because it's private. So let's go ahead and make this actually public. And I can say Frogger respawn. And let's rearrange this. Let's make sure we're turning on the home first, and then we will respawn Frogger. And let's go ahead and test these out. So there's two cases where we respawn that we should test out. So first is when you die. There's a 1 second period, and then I respawn. Perfect. And when I die, I can't move, but I just instantly died again. And then, yeah, as soon as I respawn, I regain control. And here, when I, boom, reach the destination, I now respawn again. But that happened instantly. There should probably be that same buffer period. I just closed my thing again. I didn't mean to do that. There should probably be that same buffer period where, it doesn't happen immediately. So we'll do the same thing. Frogger invoke name of, will this work? Frogger.respawn? Yeah, I think it'll still work. There we go. So it's a little confusing, but we're invoking it on Frogger for the respawn function that exists on Frogger. And then I think that's valid code. Let's see if it compiles. Yep, we're good there. Cool. All right, beautiful. And there we go. Oh, so, okay, so it worked. There was a buffer, but you can then see Frogger kind of standing on top of the thing, and it looks weird. So what we should probably do is maybe turn off the object entirely. So we can maybe say Frogger is like turned off. He's like invisible. You can't move him anymore. Then we trigger this little buffer period. And then since we've turning him off, we need to make sure we turn him back on when you respawn. So game object set active to true. Oops, not tree. True. True. There we go. Let's test that out. And it should be good. Confident this time. All right. Play. Oh, I died. Let's run. And boom. So he disappears. After a second, he respawns. So that looks good. Respawning is good. All right, now that we have respawning, we need to really tie everything together. So we need to focus on the overall state of the game. You know, starting a new game, starting a new round, things like that. So let's go ahead and create a brand new script called Game Manager, which is going to manage the state of our game. Game Manager. We'll go ahead and add a brand new empty object to our scene. We'll call this object Game Manager. Can't type Game Manager. Let's reset it and let's drag our script onto there. Let's go ahead and edit this. And so the first thing we need to start to think about is what is like our game loop, basically. You start a new game, then you start a new level, and then you start a new round. Right, so like thinking from sort of a macro to a micro perspective of what does an overall game look like? What does one level look like? What does one round look like? But we know we're going to need functions for each of these respectively. So let's add these for now. We have a new game function. We have a new level function. And we have a new round function. And so let's break down what each of these means. A new game is you starting obviously completely fresh. Zero score, you know, whatever initial amount of lives you have, everything starts fresh. When you start a new level, this happens when you clear all 5 homes. As soon as you occupy all 5, you start a new level and they become deoccupied again, and then you can do it over again and continue gaining more points. And every time you clear a level, you gain like 1,000 points or something like that. And then a new round is every time you occupy one home, you are like starting a new round. And this is important because in Frogger, there's a timer that goes when there's a timer that keeps track of how long it takes you to clear or to occupy a home. And the faster you do that, the more points you get. And so we're going to treat one of those as a round. So we got to think about what are all the things we need to do within each of these functions. Well, for new game, we need to reset score, lives, things like that. We don't even have variables for those, so let's go ahead and add that. Score, lives, and we know immediately we should set these to 0 and set lives to 0. Or lives to, let's say, 3 initially. And actually, before I get any further, I'm going to, once again, I'm trying to think ahead a little bit here. It's always a good thing to do as a programmer is to start to think ahead of what problems might come up in the future. Eventually, we're going to add UI. So every time I change one of these score lives, I also need to set the new UI. I need to update the UI. So there's always going to at least be like 2 things that need to happen. So I should probably have functions for each of these. Set score to some value here. And I can also have set lives to some value. And so here we can set our lives, and then later on we'll add our UI here. And then same thing here. This dot score equals score. I have to use the this keyword here to make a distinction between the parameter and the actual, you know, the actual class member here, because they have the exact same name. So this is referring to the instance of the class, and then we're accessing the score, versus this is just referring to the parameter. And yeah, same thing. We need to update UI. We'll come back to UI later though. But so now let's change these to be set score to 0, set lives to 3. You can change that however you want. And then we should start a new level. Okay, so now what do we do when we start a new level? Well, once again, we indicated that a new level is when you've cleared all of the homes, you've cleared the level by occupying all the homes, then you start a new level. So we need to make sure we go through all the homes and reset them back to their default state. So first, to do that, we need a reference to all the homes. So let's create a variable. We'll call this will be an array of homes. And we can assign this value in our awake function, which is usually where we assign references to other objects. So we can say homes equals find objects, plural, of type home. This will search through our entire scene and return us an array of all of those. And then here, when we start a new level, we can loop through homes.length, I++. We're just normal for loop here. We'll access each home in the array and set its enabled state back to false. False indicating it is not occupied. So when you start a new level, the homes are not occupied. Thus, you can occupy them and gain points. And when you start a new level, well, you should also start a new round. So we're just, once again, we're just kind of breaking down layer by layer of what should happen. So now what happens when you start a new round? We're going to need to respawn Frogger. So let's get a reference to Frogger. And let's establish this here. Oops. Frogger equals, this one will be find object, but singular this time. Find object of type Frogger. And we can say Frogger.respawn. Perfect. And there will be other things we do in here, but that will tie into scoring. So we'll come back to that. For now, this will be all we do. And I think that's good for now. Let's go ahead and at least test out that you can... so we need to start a new level every time you occupy all 5. So that's what we need to determine. How do we know once you've occupied all 5? Well, what we can do is when you've occupied one of these, we can inform the game manager, hey, this home has been occupied. That might then trigger a state change in our game. And so the game manager manages all those state changes. Our home here should just inform the game manager that some event has happened. Right? So we can add a function. Let's add a function to our game manager. It's going to be public because we need to call it externally from our other script. And let's say like a home has been reached, or maybe occupied is better. Home has been occupied. So we're informing the game manager that this thing has occurred. What should happen? Well, score will need to be changed. A number of things will need to be changed. We're going to focus on scoring as its own thing. So we'll come back to that. But what are some other things that need to happen? We need to check if you've cleared all of the homes. And once you've cleared all of them, then we need to start a new level again. So how do we check if you've cleared all of the homes? Oh, and first let's call this. So we can say find object of type, game manager, and home has been occupied. So we're informing the game manager that the home has been occupied. Great. So we should check if you've cleared all of the things, and if you have, we'll start a new level. Otherwise, we just start a new round. So let's add a function that returns a Boolean. It's going to return true or false, whether you've cleared the level. And we know if we've cleared the level if all of our homes are enabled, indicating they're all occupied. So we can loop through our array of homes I is less than homes.length. And in here, if a home is enabled, homes I is enabled, or what we should really do is say if it's not enabled, then we immediately know you've not cleared the level and we can return false. So that this means there's still a home that has yet to be occupied. Therefore, the level has not been cleared. We return false. If you make it through the entire for loop without ever returning false, well, then that must mean all the homes are enabled, they're all occupied, and therefore we have cleared the level, so we return true. And so now here in our function, we can say, if you've cleared the level, we will start a new level, else we'll start a new round. And starting a new round will respawn Frogger. And so notice here that in our home script, we are already telling Frogger to respawn. So we don't need to do this anymore because this function is going to handle it for us because we start a new round, Frogger respawns. So we actually can get rid of this. We can get rid of all of this actually. We do need to make sure Frogger gets turned off again, but we don't need any of that code anymore. The only thing we need to the only line of code there we need to make sure we keep is that Frogger gets turned off temporarily. And remember, we added a little buffer. We added like a 1 second delay between when Frogger respawns. We're not accounting for that here. So what we should do is that same thing we did in Frogger respawning by invoking these things after 1 second. So we can invoke name of new level and give it like a 1 second grace period. Same thing for starting a new round. Name of new round, 1 second buffer period. And then when new round starts, Frogger respawns, and so all's good. And when Frogger respawns, yeah, he still gets turned back on and so on. So we're all good there. Let's go ahead and test this out. I'll try to beat all 5 really quickly here. 1. And here's 2. 3. And 4. One more. Hopefully this works. First try. Sit here and wait. So this last one can always be a little bit tricky because you gotta wait to the very last minute. And 5. Boom. I respawned. They all got cleared again, which means we've started a new level. So that's all working perfectly. And then we can tie in scoring and so on as we progress. But that's a good start. All right, let's go ahead and tie in scoring to our game. Now we already have all the right pieces in place. We just need to basically update our score every time certain events happen. So the first thing we need to do is when you occupy a home, we should increase our score. So when you occupy a home here, our score increases by 50 or by 50 points. Yeah, so score is going to be score plus 50. When you clear an entire level, we get 1,000 points. Boom. And now when we, let's see, when you occupy almost 50 points, you get 1,000 for clearing a level. And then there's also, you get more points based on how quickly you occupy a home. So what we need to do is start a timer when you respawn. And then this will keep track of how much time has elapsed since you've respawned. And the quicker you reach the destination, the more points you get. So let's first add a new variable to keep track of our time. Be an integer. And when we respawn here, now should it be when you respawn or when you start a new round? I think it should, I believe the original game, it resets the timer every time you respawn. So if you die, it will reset the timer. So yeah, when we respawn. Now, our respawn function exists in our Frogger script, but our game state happens here. So really we should have a respawn function as part of our game manager. And our respawn function here will call the respawn function on Frogger among some other things that are specific to their game manager. And so our new round we'll call respawn. And once again, there's going to be more we do within here in just a minute, actually. But for when you respawn, we need to start a timer. We can use a coroutine for this as well. Just like we did for Frogger, we'll start a coroutine to keep track of how much time has elapsed. So we should start coroutine. We need a function to call for our coroutine. We need to import using system.collections. And our coroutine function will return enumerator. This is why we need to import system collections, because this type exists in there. And then let's just call this timer. We'll maybe pass in a duration for how long we want it to last. And this we can call when we start a coroutine. Let's say maybe you have 30 seconds to reach the destination. And so when the timer starts, we will set our time to be the duration. So we're going to count down. So our time will be 30, and then it's going to tick down every second. So while our time is greater than 0, so as long as you have time remaining, we will yield for 1 second. We're going to yield for 1 second, and then we'll reduce our time. This is a decrement operator. It reduces it by 1. And now if the entire while loop finishes, so your time has now reached 0, well, then you didn't make it there in time and Frogger dies. So we should call our death function on Frogger, which we can't access because it's private. So let's change this to be public, and Frogger dies if you run out of time. Great. Now, one thing we need to do is before we start this timer, we need to make sure we stop it too, because if you let's say it only takes you 10 seconds to clear a level, this is still ticking. And so you're going to respawn, it's going to start over. We don't want to then start another one and have 2 timers ticking. So we're going to stop all coroutines. That way, then when we start it up again, it'll be brand new. There'll only ever be 1 running at a time. So we stop before doing anything. And now, yep, this runs. Finally, once we occupy our home, we can check how much time has elapsed, and you're going to get extra points based on that. All right, so we can say, bonus points equals however much time you have remaining times 20 is how Frogger does it. For every second you have remaining, you get 20 points. So the quicker you do it, the greater this value will be, and thus you'll get more points for it. So score plus the 50 you just get for, occupying the home, and then, plus how much bonus points you get based on time. Great. So that's one aspect of scoring. Another aspect of scoring is every time Frogger advances to a new row, he gains 10 points. So to handle this, we need to keep track of how far Frogger has moved. So let's add a variable for this as well. And maybe we do this in our Frogger script, actually. So we can add a variable to say, what is our farthest row? We only need it to be a float because we only care about it on the y-axis. We only need one axis. So this can be a float, farthest row. When you respawn, we will reset that to be 0. Or it will reset to be whatever your spawn position is. That's our farthest row. And then every time you move, right? So every time, say, okay, you're about to leap to a new destination, we can say if this new destination .y, only care about the y-axis, is greater than whatever our current farthest is, well, boom, that means you've gone even further than before, and therefore you should gain more points. And we should update what our new destination or what our new farthest row is. And we want to do this because if Frogger moves backwards and then forwards again, you're not going to like continuously gain points every time you move. You can't cheat the system and go back, forward, back, forward, back, forward. So we need to make sure you're only ever getting points if you've exceeded the previous furthest. Now we need to increase how many points we get, which is handled by the game manager. So we need to communicate to the game manager that this has happened. So we need to call some function which doesn't exist yet. So let's go ahead and add a function. Just like we did for when our home was occupied, our home script communicates to the game manager, hey, this thing has happened. Same thing needs to happen here. And maybe this will be called advanced row or something. And so when you advance a row, we set our score to be our current score plus 10 points. And we'll call advanced row from here. All right, let's go ahead and test out all of these changes. Now, we don't have any UI yet to know what these values are, but one way we can test this out is by debugging this. So in Unity, you can click the three-dot menu here and go to debug. And now I can see what these other values are while the game is running. And notice they're all 0, which is incorrect. And that's because I just realized we never called new game. 0 references. It's never being called from anywhere. When our script first starts, we need to start a new game. So that is just a mistake from earlier. Let's fix that really quickly. Let's try this again. Play it. We should see these. Yeah, so score 0, lives is 3. Our time is already ticking down. So let's go ahead and, yep, so notice I've already gained 60 points. Every time I gain. Now, if I move backwards and then forwards again, I didn't gain any points because I haven't actually advanced any further. I should get 50 points when I enter, plus however many points I got because of my time. And now I can go again, and I'm gaining 10 points again because it resets every time you respawn. Perfect. Great, that's all working wonderful. Okay, just a few more things left to do. Let's go ahead and add lives into our game. We already have the variables we need for this. We just need to implement it in a couple more places. So in our game manager, we've got lives. We're setting our lives to 3 initially when we start a new game. What's missing is we aren't decreasing the amount of lives we have when we die. So that's something we need to fix. So in our Frogger script is our death function. And just like we've done in a couple other places, we need to communicate back to the game manager that there has been a state change so the game manager can update all the appropriate variables, such as lives. Let's go ahead and get a reference to our game manager. And we can call a function on here to let the game manager know that Frogger has died. Let's go ahead and add that function just like we've done for these others, advanced row and home occupied. These are really just functions that are called externally to let the game manager know some state change has occurred. So let's add one for when the Frogger has died. I'll just call it died. And when Frogger dies, we can decrease our lives. So we can set lives to our current amount of lives minus, or our current lives minus 1. And from here, we need to check if we have any lives remaining. So if our lives is greater than 0, well then we can go ahead and continue the game and respawn. Otherwise, we have to call game over. So I'm going to do what we've done in other places where I'm going to use invoke to give a little bit of a buffer period between respawning. So for example, down here, when we start a new level, start a new round, we invoke with a 1 second buffer just to give a little bit of delay between those things happening. Same exact thing here. I will respawn after 1 second. And this is if we do have lives remaining. If we don't have any lives remaining, well, then we need to call game over. We don't have a function for game over yet, so let's go ahead and add that now. Game over. And so in this case, we will invoke that after 1 second as well. So this is when we're out of lives, we will call game over. We'll come back to this function. We'll implement that next. But let's at least get the placeholder in there. Now we just need to call our died function back in our Frogger script. And now here's a thing too, where our death script is calling respawn, where this now shouldn't happen because our game manager is going to determine if you can or can't respawn. If you're out of lives, then we don't want Frogger to respawn. So we don't want to actually do this anymore inside here, because It'll be up to the game manager to determine if it should or should not respawn the player. Perfect. Okay. And then is there anywhere else we need to update lives? I think the only other place we could perhaps is when you clear a level, maybe we reward the player with an extra life, a little 1-up. So we can say set lives to lives +1 here. You don't have to do that, but I feel like that's a nice thing to do to the player. I'm not actually sure. I honestly don't know what the original game does if they give you an extra life, but you know, we can make our own version of it here. And one thing I'm realizing now is I thought we were going to utilize this new round function some more, but I don't think we are. I don't believe there's anything else we need to add to this. And so since it's simply just calling another function, we actually can get rid of new round and just simply call respawn. So everywhere we're using new round, we can just call respawn instead. Just kind of clean that up. Don't really need it if it's not doing anything extra. And there's one other place down here, so we'll search that out. You don't have to do that. I just thought I'd clean that up real quick. But let's go ahead and test if our lives is changing appropriately. I'm going to select our game manager. I'm still in the debug mode, so I can see some of these private variables. So initially, we should start with 3. If I die, it goes to 2. I still respawn like I should. And let's see if I run out of lives. So I'm at 1 life left, and I die again. Now I'm at 0 lives. And see, I'm not respawning at this point because I've gotten a game over. We don't have any game over UI yet, but that will come next. But this all appears to be working, so we're good there. All right, all we have left to do is add our game over and our UI. And we can start to add some of our UI as part of our game over step here. So we added our game over function previously, but we haven't done anything inside of it yet. So let's think about what we want to happen when you get a game over. In our case, I think what I want to do is hide Frogger entirely and display some game over menu, some UI. And then from there, the UI will prompt the user to play again, and maybe they have to press enter on their keyboard in order to start the game over again. So let's walk through those steps. First, let's hide Frogger. Let's set him to be inactive entirely. Guarantees you have no more control over Frogger. He's not randomly displaying on the screen. Everything's good there. So we just turn him off, and he will already turn back on the next time he respawns. That's something we already are handling, and our respawn function is to turn it back on. So we're good there. So we turn Frogger off. We need to display some game over menu, which we haven't created yet, but we can at least have a reference to it. So here I can have a public variable, and this is just going to be a game object because it might be a collection of multiple elements. So I can't say specifically if it's going to be some, component or some script or whatever. So I'm just going to say game object, so it can essentially be anything. And I'm just going to call this maybe game over menu. And so with this variable, we can turn that on now. So game over menu, set active to true. Okay. And then from here, we need to check for input to see if the player wants to play again. After they press enter, they can play the game again. Or it'll start over and we'll call new game. So why don't we do what we've done in other places, which is use a coroutine. Go ahead and add one here. enumerator is the return. And let's just call this maybe check for, play again or something. Or we can just simply call this play again. Okay, and so we'll store this in a Boolean to say, no, the player does not, by default, they say false, the player does not want to play again. And we will set this to true as soon as they have pressed a certain key on their keyboard. So we can say while they have decided to not play again, we will continue to check for input to see if they have pressed a particular key. So if input get key down, key code, let's say, enter or return in this case is actually what it's technically called. We will set play again to true. which is going to stop our while loop, and therefore we no longer need to check for input. And so, oh, and then one more thing is, in any coroutine, you always need to yield at some point. So we need to yield, and we don't need to yield in any particular way, so we can just return null like we did in Frogger. This is just going to yield into the very next frame, and then it's going to check again. So it's very similar to like what a normal update function would be doing. It's just kind of encapsulated within this little coroutine. So finally, once they have pressed return on their keyboard, play again gets set to true, which breaks the while loop, no longer yields, and now we can finally call new game. New game gets called, score gets reset, lives gets reset, a new level starts, which resets the homes, which then also respawns Frogger. The only other thing we need to do in new game is we need to hide this UI that we've added here. Oh, and also we never started our coroutine, so let's go ahead and do that. Start coroutine, play again. And just to be safe, let's stop all coroutines before starting this one. There shouldn't be any other coroutines running at this point, so we'll make sure by stopping them all before we start our new one. And then back to where we were in our new game, we just need to simply hide that game over menu. When you start a new game, we no longer want to see that stuff, so we can set active to false. There we go. All right, so there's our game over. We can test this quickly. The UI doesn't exist, and so actually until we have the UI, it's going to cause an error because it's going to try to do some stuff with that code, but the object doesn't exist, so we're going to get a null reference error. So let's go ahead and create our UI really quickly, or at least get something in place. So to create UI, we need to add a canvas. If we click our plus button here, we can go to UI, we can go to canvas, and then canvas will allow us to render some UI on top of our screen here. By default, it renders the UI in screen space. We can right click our canvas here and add some additional elements such as text, buttons, whatever we want. For our UI menu, it's going to be comprised of multiple elements. So I need some parent objects to contain those several elements. And so I'm just going to right click and choose create empty. And I'm going to call this game over menu. And then as children of this object, we can add various elements like text and so on. But this is the object we will reference in our game manager script. So we can reference that there, make sure we drag that in. And that's at least enough to make sure we're not getting any errors when we run the script. So we can at least test this out at this point. And let's go ahead and see. Let's just run out of lives real quick. 1 life left, 0 lives left. So after a second, I disappeared, but I haven't respawned. All right. So it's at this point, it would be prompting me. Oh, and you can even see that our game over. Oh, yeah, our game over menu has been activated. It's enabled right now. So we obviously haven't created the UI, but it would be prompting us, hey, would you like to play again? If you do, press enter, right? So right now, if I press enter, there we go. I respawn. The state of the game resets. I'm back to 3 lives and so on, and I can continue playing. So perfect. So that's it for our game over. So the final thing we can do now is just simply add some UI to tie everything together. But other than our UI, our game is fully complete. So let's try to quickly run through some UI. I usually, in a lot of my tutorials, skip the UI just because it eats up a lot of time, but I think we can go ahead and implement this fairly quickly. The only thing I'm going to add to our project is a new font that matches the style of our pixel art a little bit more. So I'm going to create a folder for this called fonts. I'm going to drag this in. This font, just like the rest of our assets, are available on GitHub. Link in the description of the video. You'll be able to click that download button just like you might have done when we imported our sprites at the very beginning of the video. But also, once again, feel free to use your own fonts. And of course, Unity has a built-in font that you can use too, but this one will fit our style a little bit better. So let's go back to our canvas here and let's add some, various elements. We need score, lives, timer, and our game over, of course. So let's just kind of start. Well, let's start with our game over since it already exists. Let's add some text here. And we can, let's see, text. All of our properties here for our text. We can't really see it at the moment, but as soon as I make this a little bit bigger, we should, oh, actually you can see it. It's just so hard to see because of the color. So for one, I'm gonna make it white. Two, I'm gonna make this much bigger. Now, when I make it bigger, it starts to clip past the, based on the size of this text box, it's now too big to fit within this bounds. So sometimes what I like to do is intentionally allow it to overflow beyond the bounds. So I let it overflow, and then at which point the width and height doesn't really matter in a sense. So we can sort of just zero those out. And I'm going to center align the text. I'm going to vertically middle align it as well. And this, we can just say, you know, game over. I can assign my font here. Let me reposition it like just over the median there. So maybe -42. Could probably be a little bit bigger. Let's say 40. That looks pretty good. And maybe I want to add a black outline to it. So Unity has an outline component here. And let's maybe bump this up to like 16. Oh, no, that's too much. Let's do 4 and 4. Yeah, and let's give it no opacity. So give it a little bit of an outline there. So it's a little bit more readable. Maybe 2 and 2 or 3 and 3. That looks good. Okay, so we've got game over, and I'm actually going to fully capitalize this too. It displays a little bit, this particular font uses a little bit different characters when they're capitalized. So there's game over. And then maybe we have a second text element at the top of the screen that says, you know, press enter to play again or something like that. Or no, we'll add it on the bottom because the top we'll use for our score, our lives, our timer. So we'll put it at the bottom right where Frogger would normally be because that's probably where the player is going to look. So we'll put it down there and say, hey, press enter to play again. Now, if we click this thing in the top left, this allows us to anchor our UI element to part of the screen. So in this case, since it's going to be down there, I want to anchor it to the bottom and in the middle. Oops. And now, when we set our position here, we can, it'll be relative to that location. And let me see here. Oh, and you know what? I don't know why it's actually not working. It should. Oh, it's just because our font's so big. Yeah, it's just because our font's so big. So at that point, it like doesn't matter. But that's okay. Let's go ahead and just position this at the bottom. And we can say, press enter to play again. Oops, let's do just center it like right there. That looks good. Let's make it maybe a little bit smaller, maybe 36. Press enter to play again. Perfect. So this because both of those are parented to our game over menu, this entire menu will display and hide when we start a game, and of course when we get a game over. Let's add our score and lives. So I'm going to add these not as part of game over menu, but just as their own thing. Text here. You know what? I will duplicate these other ones because they already have all the settings we pretty much want. So let's duplicate one of those and just drag it outside of there. Let's anchor this one to the top of the screen instead. There we go. See, this one worked. I don't know what happened with this bottom menu, but something's not right there. Normally, if you anchor it, it should, you know, reposition just like it did for the other one, but that's okay. For the top here, right in the middle, we'll have our timer. So maybe by default, we'll just say 30. Position this, you know, right there looks good. Let's go ahead and let's actually give this a name. We'll call this one time. Let's duplicate that. Let's anchor this to the top left. And we can call this one score. And this one should be left aligned. And now let's offset it from the edge just a little bit here, maybe by 20. So this will be score. Let's duplicate this one more time. Let's right align this one. Or anchor to the top right. Let's right align the text. Let's offset it as well by like 20. And this will be for our lives. Now for our lives, we should probably, just so the player knows which is which, maybe we want to display a little Frogger icon next to there. So to do that, we can create, first let me rename this to lives. But to do that, we can create a little image element. So we can right click our canvas, select an image, and here we can use a sprite just like we've done for everything else. So we can maybe use a little Frogger sprite. We will anchor this to the top right, zero it out. Here you can see that the middle of the frog is right at the corner, and that's where this pivot point might come into play. So we can change the pivot point to, in this case, 1, 1, and now the pivot point is in the top right corner. And so when I zero it out, it's at the top right. Now our frog as a whole is way too big, so we definitely want to make him smaller. So let's decrease width and height, maybe even a little bit more. So maybe just do a 50 and 50, 54 and 54. That looks pretty good. We'll center him a little bit, maybe -4. Let's push him over as well, maybe -8. So that looks good. And let's just move over our text so it's next to it. Maybe -64. That looks good. Maybe we decrease the font size a little bit. There we go. So that looks pretty solid. So we've got all of our UI elements in place. Now we just need to hook these up to our game manager. So our game over is already good, but we need to add the others. So we need to get a reference to all those text components. To do that, we need to import using Unity engine.ui. And now we can reference all of these things as text components. So we can say score text, we can say lives text, and we can say time text. Okay, and then in our code, we've already added 2 functions for setting our score and lives. We did this quite a while ago, but we even put a little comment here to say, hey, we need to do our UI. And so this is nice because everywhere that we're changing our score and lives goes through these functions. So now all I need to do is here is say score text dot text equals score to string, and same thing for lives. Lives text dot text equals lives to string. And so our score and lives are good. The last thing is our timer. For our timer, everywhere we update that in our coroutine here. So every time we decrement our time here, we should update our timer text. So timer text or time text. Oh, and I misspelled that. Yep. Time text dot text equals time to string. And we should do it when we first set the duration too. And there we go. There's our UI. I know I did that pretty quick. I don't want to spend too much time on the UI because there's 1.5 million ways we could customize our UI. Now I got an error, no reference exception. That's because I forgot to assign my references here. So it's trying to do stuff in the code, but those objects don't exist. The code has no reference to them. So we need to make sure we assign these score to score, lives to lives, and time to time. Let's run it again. All right, our lives is 3. We can see our time is ticking down. And as I gain points, our score in the top left is increasing. So everything looks to be working. Score, great. Let's check that our game over UI displays when we lose. So let's go ahead and just die real quick. Game over, press enter to play again. Let's press enter. Boom. I respawn, timer resets, score resets, lives reset, everything is working perfectly. And so there we go. That is our complete game of Frogger. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel for more videos just like this one, and leave a comment recommending what you would like to see next. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including access to the Unity assets that I develop. Link in the description of the video. Thank you for watching. See you in the next one.